This video is about the comparison of the difference between displacement time graph and velocity time graph. So before you start to watch this video, it is very important for you to read your notes pertaining to the difference between the two, because if you don't have a very good foundation on that, this video will be quite confusing, especially when I give you the examples. Alright, so make sure that you read your notes before you watch this video. So next, I'm going to just summarize the differences between displacement and velocity time graph. So first of all, for displacement time graph, if we are reading the y-axis, obviously the y-axis will give you the displacement. Alright, for velocity time graph, the y-axis will give you the velocity. So this is very straightforward. Now, if you read the gradient in a displacement time graph, it will give you the velocity, while if you read the gradient in a velocity time graph, it will give you the acceleration. For the area under the graph of the displacement time graph, it doesn't have a significant meaning to it, so you do not have to know this. But for the area under the graph of a displacement time graph, velocity time graph, it will give you the displacement. So this information and this table, you must make sure that you already have a clear understanding and have this knowledge at the back of your hand. Otherwise, doing the questions later will be rather confusing. Alright, so let's start. What I'm going to do is that I'm going to put two identical kinematics graphs side by side. Okay, the only difference between the two is that one is a displacement time graph, as you can see here, while the other one is a velocity time graph. Other than that, the values and the shape of the graph is identical. The reason for this is that I want to show that just by not reading carefully the y-axis, whether it's denoting displacement or velocity time graph, you can have a totally different answer. So what is happening is that in both questions, I'm actually asking the same thing, but you will realize that the outcome is very different. So in the first case, we would like to ask, describe the motion between 0 to 5 seconds and 5 to 20 seconds in both cases. Now, if you want to answer this question, you may pause the video at this point so that you can answer and see whether you get it correct. It goes the same for the other slides that I'm going to show. Okay, so for the first one, describe the motion. Must remember that the key to describing motion in both cases is of course the gradient. Alright, so I'm just going to write it down here. But of course the gradient in both cases is very different. In the first case, alright, for displacement is the velocity, while for the velocity time graph is the acceleration. Alright, so because of these two differences, the first answer will be constant positive velocity, while the second answer is actually zero velocity, but you do not write as zero velocity, you say it at rest or stationary. Now for the second case, since it represents acceleration, this becomes constant positive acceleration, while for 5 to 20 you will represent zero acceleration, but again we do not write as zero acceleration, we write as constant positive velocity. See the difference between the two? The answers are very different. Now using the same arrangement, let's look at another two questions. Okay, so for the second case, it is the second question with the identical kinematics graph again, is to determine the velocity in both cases. So as you remember from the summary table, that the velocity in the displacement time graph is the gradient. Alright, so you have to use the gradient to solve. However, for the velocity time graph, it's just read from the graph, right? Read from y-axis, right? So if you want to find the gradient at 3 seconds, some students will say that first of all I need to read the graph at 3 and then find this unknown value here. But since I do not have any information, I cannot determine the gradient. That's not true, because you need to know that the whole line here is a constant gradient. Alright, so if it is constant, so what's going to happen is that the gradient throughout this region is the same. Alright, so if I take 20 divided by 5, I will give you the same gradient as between this point, and this point. They will be the same gradient. So because of that, I can actually say that the gradient at 3 is the same as the gradient at 5, so it's going to be 4 meters per second. Alright, so in the same way for the velocity at 15 seconds, alright, which is somewhere here, the gradient will be the same throughout here, which is a horizontal line. So the gradient is going to be 0, and yeah, so the speed is going to be, velocity is going to be 0. Now for the next case, if you want to find the velocity at 3 meters per second, in this case you really have to read the value at 3 meters per second. So of course this diagram doesn't give you the grid line to read, but in the actual examination there will be such grid lines. So in this case, just for convenience sake, you read the graph, you will get around 15 meters per second, and for 15 seconds you will be somewhere here, so it will be 20 meters per second. Alright, again you can see the difference in the answers between the two. Next, alright, we're going to go to determining the displacement. So in this case, the displacement is just to read from the graph, alright, while the displacement in this case, you need to use the area under the graph. Right, see the difference? Both has very different methods. So if you want to read from the graph, okay, at 5 seconds the displacement is obviously 20 meters, and then at 20 seconds it will still be at 20 meters, there won't be any changes. For the displacement in the velocity time graph, after 5 seconds it will be the area highlighted in blue, which is half times 5 times 20, which is 50 meters. Now for 20 seconds it will be the area of trapezium highlighted by the shaded region, which is going to be 350 meters using trapezium rule. So this will be 15, while here will be 20. So it's half times 15 plus 20 times 20. Right. So that's how you get your area under the graph for 20 seconds. Alright. So let's move on to acceleration. Usually for displacement time graph, they seldom ask about acceleration. It's not that it cannot be asked, but usually it's not asked, but it still can be solved, right? But I'm not going to explore this for this particular question. Alright, so I'm going to go to velocity time graph. The acceleration is obviously the gradient. So in 3 seconds, again, we do not need to know at 3 seconds what is the value here. We do not need to know because the whole graph has the same gradient. The whole line has the same gradient. So we can just use the rise over run of from 5 seconds. Alright, so the gradient is 4 meters per second square. Now for 15 seconds, again, we can use the whole line here. So the whole gradient is 0, so the acceleration is 0 meters per second square. Alright, so let's move on to something more challenging. Okay, we're going to deal with a kinematics graph where it goes from 20 to minus 20. So it goes from positive to negative values. Again, we are using two identical graphs to do a comparison. Okay, once again, describing motion, remember we have to read the gradient, and the difference between the two gradients is that this is the gradient is velocity, while this gradient is acceleration. So you can pause the video again if you want to try it yourself before I review the answers. So for the first one, 0 to 5 seconds, it is actually at rest because the gradient is 0, 0 gradient, 0 velocity at rest. Second one is negative, so it's constant negative velocity. Negative gradient, constant negative gradient, constant negative velocity. For describing the motion, 0 to 5 will be 0 acceleration, but you don't write as 0 acceleration, you write as constant positive velocity, while for 5 to 15, constant negative acceleration. Okay, no issue with this. Let's move on. Now, what if you need to determine the velocity at 3 seconds and 10 seconds? So again, the velocity is found using the gradient. Okay, and then for the velocity time graph is found using the by reading the graph. So see the difference between the two. So the gradient in this case for the first 3 seconds again is just the same. Alright, so from 0 to 5 seconds the gradient is the same. So at 3 seconds it will be the same as the rest, 0 meter per second. Now for the 10 seconds, okay, which is somewhere here actually. Alright, the gradient will be this whole line. Again, the whole gradient, alright, is the same. So you do not need to know the gradient at this point. You can take the whole line to find the gradient. So by taking the whole line to find the gradient, I can take from here to here for the rise, and from here to here for the run. So from here to here is 40, while from here to here is 10. So take note there is a negative gradient, so it's minus 40 over 10, so you get minus 4 meter per second. Alright, so in this case, when you want to read the velocity, the first 3 seconds will be 20 direct from the graph, while for the second one, if it's at 10, alright, it's here, so the velocity is 0. Okay, so moving on. If you want to find the displacement, again, this is just reading from the graph. While the displacement here is to find the area. Okay, so see the difference between the two, very different methods. So if you read from the graph, the first displacement will be 20. Okay, so because at 5 seconds it will be 20 meters displacement, while at 15 it will be minus 20. Right, simple. Now the next one is for this one at 5 seconds it will be this region here, so it will be 20 times 5, which gives you 100 meters. For 15 seconds it will be a bit more challenging, okay, because you need to understand what's going on for this journey. So for this journey, I'm going to draw it here to explain to you what's going on. So for this journey, what's happening is that it is actually an object that's moving upwards. Alright. So as it moves outwards at constant velocity, it covers a region A. Alright, so this is region A. After that, it slows down to 0. So slowing down to 0 is actually a path like that. Okay, going to a maximum height. So let's say this is a region B. It will be this region here. And then after that, region C will be where it goes backwards. Alright, region C. So what happens is that the object goes up some more to the highest point, and then it goes down to the same point it reached when it traveled through along A. Alright, so this is the path it goes. And A is 100 meters. B, if you calculate, is 50. And C is also 50. So if you can see that how the diagram is going to come out, alright, you can actually judge the displacement travel. From here, you straight away know it's 100 meters. So actually what is happening is that it is actually this area minus this area. Alright, so it's this area which is given by here. This is a trapezium minus this area. Alright, so this is half times 5 plus 10 times 20, which is this area. So this A plus B, and then this is C. Half times 20 times 5, so you get 100. Okay, so that's how you find the displacement. So the next question is obviously to find the distance. So to find the distance is a little bit more challenging. Do remember that distance is the total change in displacement. Alright, so this is actually a change in displacement. So remember that in the first 5 seconds the displacement has not changed, so there is no distance covered. Alright, so you read from the graph, it's still 0. Now for 15 seconds the displacement go from 20 to minus 20, so actually there is a change of 40 meters. Alright, so for the distance travel is again using the area under the graph. But this is a little bit more tricky in the sense that let's draw the diagram again. Okay, so what's happening is that this is A, this is B, this is C. A will be 100, B will be 50, and C will be 50. So for first question, 5 seconds, it will just be the distance travel in A, which is 100 meters, no issue, very similar to the previous questions. But for 15 seconds, it will be A plus B plus C, A plus B plus C. Alright, so the difference between displacement and distance is that displacement is A plus B minus C, but for distance is A plus B plus C. Alright, so in this case, the answer is 200 meters. Okay, so this is the end of the video for this explanation on the difference between the two graphs. So I hope that this will help you to understand the importance of reading the y-axis or knowing whether it's a displacement or velocity time graph before you start doing, because the outcomes will be very different. So thank you and have a nice day.